Hi guys, today we are going to talk about how to deploy the microservices into AWS EKS, the AWS Kubernetes engine. In the last video we saw the same example, movie catalog example deployed into the GCP Kubernetes engine. So I was since the Kubernetes is supposed to be portable, so I was very curious to see how portable it is. So I just want to check that. So this video is going through um, the steps what it involved to make the Spring Boot web service. Here, basically, a movie catalog is a composite service, and which is calling the movie rating dependent service, and the other dependent service is movie info service. Um, and it is since it's using a Kubernetes, the referring from the master from the composite service to the dependent services is using the Kubernetes DNS way, and hopefully the assumption is I don't have to change the concept what I did for GCP Kubernetes and see it should work. Okay, so we will see that. Okay, so that means in the YAML configuration, I didn't change any code. The Spring Boot code is same as it is, but in the YAML configuration, um, see, this is the movie catalog metadata defined, right? Which is having the dependent service using the environment variable, movie rating with the DNS of movie rating, movie info URI using the dependent DNS of movie info. And also I was having a Spring Cloud GCP trace enabled for the GCP side. When I deployed with that, it was giving an error. So I figured it out. Okay, so I just changed the value to false. And in the Spring Boot project, in the pom.xml, it was having a couple of entries for the stack trace thing. I thought, okay, I don't even want to touch it. If I just change this particular value, will that work? And that is what it is working. So that's what we are going to see today. Okay, so the same, almost the same diagram. So AWS Kubernetes Engine EKS also has the same structure. So all these guys, Azure, Google, and AWS, all these guys are taking the same open source thing. So that means the concepts are same. It has the cluster and uh, there are nodes available, and within the nodes, the deployable unit is the pod, and the container images, Docker images is running on the pod, right? The containers in the pod share the networking and storage. That means one pod can able to talk to the another pod using the private IP, and it can share the same storage as well. So this is the plain vanilla Kubernetes. If you don't touch anything, if you want to have more restriction, uh, can you do it? Yes, you can do it. That means it's more proprietary way of doing. But right now, I'm just trying to see what is the base thing we are getting. Okay. Okay, I just want to talk about the comparison between GCP Kubernetes with AWS EKS. The thing is, for the GCP, we have the console comes, and many things are preloaded. As soon as you log in into the GCP console, you can go to the Cloud Shell, and through Cloud Shell, you get many of the prepackaged thing. But in AWS, we don't have the concept called Cloud Shell, right? So that is one of the reason it has some learning curve involved. So in GCP, once you create a Kubernetes cluster, it creates both the control plane and worker nodes. Here, these things has to be installed manually. Okay, but in AWS, ideally, you need to create the control plane, worker nodes separately along the VPCs, ASG, auto service groups, everything. But there is a utility called EKSCTL, and if you go into this link, you'll see more about the steps of it. Simplify the creation to an extent. but to install EKSCTL utility in Windows machine, we have to install the command line utilities, and that itself is a huge process. And I actually spent almost 5 6 days to figure this out. But once I figured it out, it's not that hard. So for the steps we have to have in your Windows laptop or something should be, you should have that AWS CLI aw.exe to be installed on your installed, and it should be in the path. Kubernetes.exe has to be installed and should be in the path. And AWS IAM authenticated.exe has to be installed and should be in the path. All you guys have to do is just to Google this, get those executable, put it in a directory, and put it in a path. Once you do that, we need to install something called EKSCTL, right? That is the whole purpose. But to install EKSCTL, we need to install Chocolately. And it took some time for me to figure that out. You have to go to the command prompt or PowerShell in the admin privilege mode, and you have to say curl command. This comes from the ViewWorks, the partner. And so first you have to get that thing. Once you got it, then the second step is Chocolately install EKSCTL. So this is what is installing the EKSCTL utility. Then the next couple of commands, it's basically completing that utility. So you have to create a directory, and you have the EKSCTL completion. You have to follow it through. So once you do all the way, then you are ready to create the cluster. So now EKSCTL create cluster minus region. Your region, I have used US East 1 minus name, and I used the cluster name. Once you do that, then it's the above command creates the EKS cluster, worker nodes, creates the AWS EKS config file under similar directory like this. So I just want to go into the demo mode now, and just to show you guys what are the things I have to do to make this work, right? So a couple of things. One is once I go into SQL projects, utilities, I put all those common things under this utilities. So Amazon AWS IAM executor.exe, kubectl.exe, even you can use the AWS.commandline.exe. All of them, if you put it in one directory, you can put that in the path variable. So that is the trick I followed. So this is the prerequisite. After that, I went into this thing. So let me show you. Okay, so one thing is the EKSCTL command, right? That EKSCTL command, it takes 15 minutes to complete the whole thing. Okay, so once you go into this thing, so I'm trying to show you guys like some of the steps what I did. Once I started using the EKSCTL create cluster command, it took 15 minutes. But before that, the other two steps are like, remember, once I get that EKSCTL, the step is to make a directory, and then you have to say completion. So these are the steps which followed. And after that, I use this command, EKSCTL using C. And sometimes this command fails, and you should not give up. First time it did not work, as you see here. So this is for the brave hearts actually. So it took 10 minutes and gave me an error, and it internally uses the cloud formation, and the cloud formation is trying to create the cluster as well as the worker nodes. I'll show you within a minute what is that. So I once it failed, I deleted, I recreated with a different name. EKSCTL create cluster region US East 1 minus name, the IK. And now this time I didn't change anything, the same procedure, but first time it failed. Second time it created, and it's saying it's all ready to be used. Okay, so let me just trying to show you briefly what are the things. Uh, so first I'll show you here cloud formation. So it's kind of very pretty interesting actually, because this is doing behind the scene lots of things. So one thing is, see, it create EKS at 1212. See, between it first creates this cluster. Okay, it creates the cluster. Periva EKS cluster. That's the name of the cluster. And if you want to go what has been done, if you go under the events tab, you could able to say that it created ingress and the control plane, the NAT service, NAT private service, the NAT gateway. So it's quite interesting because it creates some policies on the route tables, update the VPC, create the VPC, subnet, and yeah, quite involved actually. Think if you have to do all this manually, that's where the error prone things comes, right? So it creates, just to create the cluster, it creates all this behind the scene. Okay, and now I just want to show you, if you go back. Okay, see, this is the worker node. Okay, so this is quite involved. And if you go what has been done, if you go under the events, it's also creating the node group and profile egress cluster and security group. So it's basically creating the whole thing. And if you go inside the EKS now, you see this whole has been created for you. This has been created along with the VPC, along with the subnet, along with the security group. All this came from the one place called the cloud formation, right? It creates all this. And what else I can show you here? I can show you it is running two instances. These are the worker nodes actually. So it automatically creates under the name whatever the name of the cluster, it creates the worker nodes. And so one is the control plane. The cluster sits on the control plane. Another is the worker nodes, which sits on the EC2 instances. And all these things happen just by one command, right? So all this happened. After that, what I did was I just want to update the kubectl thing, right? So let me show you here. uh, so once the cluster up and running, once I saw that, then see, all I'll be doing is kubectl apply -f movie info stack driver deployment.yaml. So even though the stack driver is for GCP, I didn't even change the name of it. All I changed was that particular Boolean value I changed to false so that it doesn't use the stack driver in the YAML file. I'm using the same old YAML file. That means I'm using the same old the Docker image as well, right? So I didn't change anything, but I'm just applying on this command prompt, kubectl um, apply -f stack driver.deployment.yaml, and this is going to create the particular thing. So for example, all I did was I just the catalog one, I did the info one apply, kubectl apply info YAML file and the rating YAML file. Okay, uh, rating YAML file. So I did all this. Then when I try to do get pods now, so now you guys get all also will get all. This is going to show you a separate thing, but this is what is showing us basically. This is showing you the the particular service names along with the external IP. And if you remember, this kubectl get all command in the GCP also gave the same kind of information, and all we will be using is trying to use the external IP and trying to go to that URL. So when I try to go to that thing, uh, so this is the URL. So this is the external IP given by the AWS thing, and 8081 catalog foo. And internally, this basically gives you the movie details. This comes from the movie info all the way. And then from here, the rating comes from the movie rating. This is a composite thing, right? So, and it tells you what pod it gave the value from, right? It gave the pod information. And similarly, for the next, it's showing you the movie info and then the rating information and tells you from which pod it brings it in, right? So in summary, what I did was the more the work is on the installation side of it. There is nothing, the kubectl minus f apply YAML file is the same thing. Get the external IP address and try to go to the URL is the same way. Nothing changed. The kubectl commands are all working fine. Only thing is to make this work, I need to take the YAML file and just change the couple of things. One is the GitHub. I just kept the same GitHub because all you guys have to do is just change what that. I'll show you page up. Uh, so this value GCP trace enable should be turned from true to false. Then the same code will work. And in the comparison, I told you the problem with this thing is since we don't have a cloud shell as in GCP, from the client perspective, we need to install all these things. And now at least I gave you guys the steps here. So if you follow the steps methodically here, and if you are lucky in the first step itself, your EKS create cluster will work. In my case, it didn't work on the first time. It worked on the second time. Just try one more time. And one more thing I want to make sure is once this command comes, right? Once you finish your create cluster command, the above command creates the EKS cluster worker nodes, etc., and also creates the AWS EKS config file in the client side. In my laptop, it creates under my user's the particular name I logged in /.aws. Open the config and credentials file and modify the AWS access key ID and AWS secret key ID. This is very important. If you don't have this properly, it won't work. So basically, this creates a .aws file. Under that, there is a config and credentials, and you guys have to go to open that file, right? And then make sure you go to the AWS console, get the particular access key and secret key available, and then you put it here. Then, if otherwise, it won't work. So the communication even won't happen. That is what I'm trying to tell you. That's one more manual step. Okay. Then what? So same thing. So demo is also done. So in summary, what we accomplished here. I want to keep it simple. If you have one Kubernetes project, if you have a YAML file, if you defined it properly, and if that particular YAML file is having an environment specific thing like a GCP stack driver thing, control it through the Boolean value. The rest of the code YAML file could be as it is. And once you follow the installation procedures, then deploying the microservices into the Kubernetes is the same process, whether GCP or EKS, right? That's something very good. I want to conclude with that sweet note that it is portable. Portable comes from many factors. One is like the Kubernetes DNS. Say, for example, movie catalogs talks to movie info as well as movie rating. The code was assuming the Kubernetes DNS procedure. Both EKS and GCP Kubernetes engine both behaves the same way. So those intricacies are all same. and you don't have to change the code. That's the power of the tool. And with the more advent of the Kubernetes on the on-premise with the hybrid cloud, this is going to be the future going to be. For example, you will have your application, some part of the secured application sitting on your on-premise thing. You'll be having a Kubernetes engine on your data center. Then you could able to span it to the cloud, and the same code should work, and ideally it should able to span across multiple cloud. And each vendor is trying to go on the hybrid philosophy. Google has came out with their new tool, and other vendors are also following it up. So this is an exciting thing where the portability is where you get out of the box using the Kubernetes. Okay, I want to conclude with this. Thank you very much. Have a great day.